Okay, so this is Mr. Great Tech Review. You are welcome to Mr. Great Tech Review Studio. You are welcome in the studio today. We are going to continue our Arduino tutorial. On our last tutorial, that should be tutorial 9, we did a little program, and that is what you are seeing on the system. We did how to turn our LED off and on. How to turn our LED off and on, and add a little delay program on our LED. So we add a little delay program in our LED. So, and this time around we used an LED. We let me show you what we did on that. We use an LED with a resistor. We use that should be 2.2 kilo ohms resistor. You can still use 470 ohms or 330 ohms resistor, and we did something like this. Okay, well, it's just for an emergency. I just have to do it for clarity so that you will understand what we are doing. But this time around, we are going to do it with breadboard. I'm going to introduce breadboard so that you know how to use breadboard. And breadboard has configurations. It has different configuration how to use breadboard. So we are going to learn how we can use breadboard and to avoid doing something like this. Doesn't look good and it doesn't look neat. So to avoid doing something like this, so I will rewind us back. I'll do a little bit of what we did on our last tutorial, and I will also teach us how to use the breadboard so to achieve this, and everything we did on our last tutorial using the silicon the solid state relay and our energy lamp. We are going to achieve that with this breadboard. We'll make everything neat and will make everything look beautiful so that it will be pleasant in the eyes, and also for decency's sake, so that it will look decent. So we are going to learn how to use breadboard. So for the subsequent tutorials, we are going to be making use of this breadboard. You can see this breadboard, they have the blue line and we have the red line, which is the positive and the negative. Okay, so that is it. And we have our Arduino Uno with me here. You can see Arduino Uno board, the Uno board. So you can see the Uno board. Let me bring it closer so that you can see. So this is the Uno board. This is the Arduino board. And on our last tutorial, we made use of this pin. We made use of pin 13. Pin 13. We made use of this pin 13 here, and the ground, and the ground, and the ground here. So we made use of pin 13 and the ground. So see 13, you see the ground pin, you see 12, you see 11, you see 9, you see 10. So we made use of pin 13 and the ground. We made use of pin 13 and the ground. So pin 13 and ground is what we used on our last tutorial. So we can try different pin. We can also use pin 8. We transfer the program from pin 13 to pin 8. All of that, you see how we are going to do it today. So how we can use our breadboard. So today is just on breadboard. For those of us that doesn't know how to use the breadboard, it looks like a rocket science. It's not a rocket science. It's just a simple physical and arrangement. If you understand how breadboard has been arranged, you will also know how to use it. So it's a very simple mathematics. It's not difficult. So we are going to learn how to use. So let's reconfigure. Let's go back to what we did. I will plug my Arduino Uno. I've already set my system. I've opened my IDE. So I'm going to plug my Arduino Uno. But let me just draw a schematic of what we just did. Okay, let me just show you the photo diagram. So this is Arduino board, and let me use green pin. This is Arduino board. Okay. Okay, so this is our Arduino board. So, and this is where we have our USB. This is where we have our USB, and on this point, okay, this is where we have our power pins. So here we have our power pins are here, and here we have our analog pins. We have our analog pins, they are here. Then this is where we have our digital pins, our output pins. You have our digital pins here from 0 to 13. So from here we have 0 to 13, and we made use of pin 13 and ground. And so we have ground here. So we have ground. I will use black to represent ground. I will use black so that I will represent ground so that you will see it clearly. Okay, very good. So I will use ground here. Okay, I will use black so to represent G and D. I would represent the ground. Okay, then we have pin 13. I will use red. Sorry, I will use red to represent pin 13. I will use red to represent pin 13 so that you will see my pin 13. Okay, so this is 13. This is pin 13. So this is just what we did yesterday, and we use our LED, that is light emitting diode. Very simple. What we did was to add a resistor to pin 13, and we have our LED here. You have our LED here. We have our LED, which is light emitting diode. We have our LED, and we connect it to the ground. We connect it to the ground. This is just what we did. So we have, okay, we have you can use 1 kilo ohms, you can use a 470 ohms resistor, you can use 470 ohms resistor. So this is just what we did on our last tutorial, and it's exactly what we did on our last tutorial. So we are going to, this is just the photo diagram of what we did, and the circuit diagram looks like this, because Arduino produces 5 volts. So 5 volts comes out of this place. This is 5 volts coming out of this place. So you have 5 volts. So the potential difference, the voltage potential from here to here is 5 volts. So you have 5 volts here on this pin. Then you have 0 volts. You have this ground is 0. You have 0 volts here. So you have 5 volts on the other side. Then you have 0 volts on the other side. So this is exactly what we just did. Okay. So that is it. This is what we did on our last tutorial. So now let me just draw the schematic so that you will understand how this thing works. You understand how it works. I will use the back. Okay, I will still use this place to draw the schematic. So I have this as my 5 volts. Okay, 5 volt supply. I have my resistor here. Okay, then, and which is plus 5 volts, and this is pin 13. Then I have this place. Sorry for using green. So I have this place. I have my light emitting diode. I have my light emitting diode. I have my light emitting diode. So I complete it with ground, which is my ground, which is the ground pin. Okay, so I have the ground pin, I have the ground pin connected to the ground pin. So this is exactly what we just did yesterday, and we supplied a voltage through our program yesterday. Through our program, we supplied a voltage through our program yesterday, and it started turning it on and turning it off. So actually what we did yesterday, we removed the LED, we added buzzer to see how it works with buzzer. We removed the buzzer, we added solid state relay, interface it with a contactor, and we saw how it works also. So the same signal flows to the solid state relay. So it's just exactly the same. This LED, we remove it with the resistor, we connected the solid state relay to it, and the same thing flows. So this is what we did. This is the solid state. So let's still have 5 volts again. I have 5 volts again. You have 5 volts again from here, pin 13. You have 5 volts again, 5 volts. Okay, you have 5 volts flows to the solid state relay. This is solid state relay. Okay, you have 5 volts flows to the solid state relay. Complete it with the ground. So this relay is relay solid state. This is solid state relay. So now, and this solid state relay has a contact, so it opens or closes the contact. So as 5 volts passes through the solid state relay, it opens the open contact, it closes the open contact, or if it is normally closed, it will open. If it is normally open, it will close. So depending on the state of the relay, if the relay is on idle state, it's normally open, it will close it. If it is normally closed, it will open it. So this is what we just did. And yesterday we used normally open relay. So we use normally open relay. We use a normally open relay. Yesterday we used a normally open relay, solid state relay. So whatever you connect via the contact of this relay, it controls it. So we connected a contactor, it controls the contactor, and we connected it connected an energy bulb, and it controls the energy bulb. So this is exactly what we did yesterday on our Arduino Uno. So using our blinking program. Our blinking program is a delay program that we just programmed yesterday inside this chip, inside this Arduino chip. So this is just what we did yesterday. So on this today, we are going to add more values to that, because yesterday is somehow we used the light emitting diode. We twisted it like this. Okay, you see what we did. So it's not normal. We don't do this type of a thing in electronics. So for practical sake, just for demonstration, I did it yesterday just for demonstration. But in real, if you want to do a neat job, you need to use a breadboard. So we're going to see how we can use breadboard. So in breadboard configuration, I have some pictures I downloaded that will help me to buttress my point, that will help me to show you how this board is being arranged. So we have also the smaller one of it. You have the smaller one of it, and this is the bigger one. Okay, and this is the smaller one. This smaller one, I believe, because it's going to sit on the shield. This is a shield. It's an Arduino shield, so you can sit it on shield, and you can route all your pins. You can also route it out. You can route your pins, and okay, this is how it goes. I think this is how it goes. I think this is how it goes. Okay, so this is how it goes. So you can route your pin like this. So now you can use here for demonstration, for practical, to experiment. You can mount your components here. So when it exceeds this, that is when you will go to this one. So, but for the purpose of this, our demonstration, we are going to make use of this. We're going to make use of this board. So let's go. Okay, so you can see the board is divided into two parts. The board is divided into two. The board is divided into two parts, and okay. The board is divided into two. So you have you have A, B, C, D, E, and you have F, G, H, I, J. So this is it. You have A, B, C, D to E has this. F to J is from here to this place. So that is it. So from here is one part of the board. It's just like two in one board. So from here you have one part, and from the rest you have the other part of the board. So this is how it works. Now from this line you see the dot. All these dots, this is where you will plug your components. It's where the leg of your resistors, your LEDs, all your components this is where you plug them. This is, see how it goes? This is where you plug them. It's just like plug and play. Okay, Okay, this is where you plug them. It's just like plug and play. You can see this is how you plug them. This is how you plug your components. So this is where you plug your components, and you can see it numbers from, it has a number. I will come close so that you see the number. So you have a number from 1. Let me come close so that you see the number. So you have from 1 to 5. So from 5 to 10, from 10 to 15, from 15 to 20. So this is the dots. So this one, line 1, 2, 3, 4, line 1, line 2, 3, 4, 5. So this is how it goes. So from here to here is on the same potential. So let's use our component so that we can text. So our slots here, then I put another component. So when you measure here to here, you have a continuity. So let's use our meter so that we can read our continuity. So you can hear the sound of the meter. You can see it. So that is it. So that is the sound. So the continuity sound, you can hear the sound of the meter. You can see. So that is it. So you have like this. You see the continuity, you see how it's reading. So it shows from this point to this point are continuous. So likewise the same to this and this. As far as you're on the same line, I'm on line 5 now. So they are continuous. Now if I jump this groove and enter on the same line here, it is not going to read. It is not going to read. So this is horizontal, while here is vertical. So this place is horizontal from here to here, from here to here, and this place is vertical. So on the positive line, you use the red one as the positive line, you use the blue one, you use this blue, which is negative on the negative line. So this is the positive. If you touch here and here, you find that there will be no continuity. So now if I remove it and put it on the positive line, let's read. You can hear the continuity is beeping. So the meter is beeping. Now you can now see that the meter is beeping. Let's test and see. So you can see the continuity. So it is showing. So it shows that there is a continuity between this line and this line, along the line. So along the positive line. So the same thing with negative line. There's a continuity on the negative line. So it's only for this negative line, which is the blue line. It doesn't connect to any other line. It does not connect to any other line. It's only on the negative line. So the same thing, the same principle applies to this side of the board. So on this side of the board, you have the same. The same is as this side of the board. So both of them are the same configuration. So whichever side you are making use of, you continue with that side. So in peradventure, you want to combine both. You can now jump from here to this place. So I can decide to jump the two positive lines and bridge them together. I can now do something like this. I put a jumper wire on the positive of the upper side. I put back on the positive, sorry. I put on the positive. So now I have combined the two positive together. Now we can see now. Let's touch the two positive and see there's a continuity between both of them. So let's see. You can see there's a continuity between both of them. You can hear the meter buzzing. So there's a continuity on both of them. So that is it. So that is how the breadboard is arranged. So you see, it's very simple. So whatever project you are doing, you have to respect the rules, these guiding principles, these guiding rules on the breadboard, and you have to respect it. You have to pay very close attention to this detail. So you have to pay very close attention to this detail. You have to understand the principle. You have to maintain the principle. You have to work with the principle on how this breadboard is being arranged. So it's very simple. The other ones, you have the rows and the columns. So the columns on this side, they are together. From top to bottom here are the same. So they're on the same potential, which is the red line. The blue line also on the same potential throughout. Why on the row? The row from one to the other end is on the same potential, 2 to the other end is the same potential, 3 same thing to 5 to the last, which is you have 60, 61, 62, 63, 64, and they have 65. So they are on the same they are on the same potential on the column. So it goes like this. This is the row, this is the column, and this is the rows. So the horizontal and the vertical line. So this is the horizontal line. They are on the same potential from here to here, only here and here, only here and here, only. Why here to this last one is on the same potential, only. So if you want to jump from another place, for example, if from here I jump, that means I've made this row, this column, and this row to be on the same potential. So I've already combined both of them. So if I put my probe here, I will still have the same. You can see it's beeping. So they are now the same. So that is it. So any place you want to jump a voltage to make a connection, you can use a jumper to jump it, or you can use a component to jump it to make that connection. So that is it. So now we are going to use it. So now we are going to do the same thing. So let's connect our Uno board with the breadboard so that we can still repeat the same. So now we can unscrew our resistor. So we can bring it out, we can separate them, we can straighten the leg of our resistor, we can keep it. Remember the polarity, like I told you, the longer leg is the positive, while the shorter one is the negative. So we can now repeat it again so that it will be more decent now. So we need jumpers to do so. So we need jumpers so that we can be able to make these connections. I go. So this is it. So now I will connect now. This is my Arduino. This is my Arduino board. So, and I have my pin 13 and the ground. You can see the ground. I will connect my ground pin. I'll connect this to my ground pin. Okay. My negative to the ground, and I'll connect my positive to pin 13. I'll connect my positive to pin 13. It's very simple. Just follow the diagram. It's the same thing. You connect your negative to ground. You connect your positive to pin 13. So to supply 5 volts. So now, okay, now this is my breadboard, my breadboard. Now in this breadboard, like I said, the longer leg here is positive. So, and I have to connect the resistor to the longer leg, so to limit the current flow according to our diagram. So according to this our diagram here, there's a resistor connected in between from the 5 volts output, which is pin 13. There's a resistor connected. So now I have to connect a resistor. Now how do I connect a resistor? So this is my positive pin, which is 5 volts pin. This is 5 volts, goes to this place, to the positive side. So this is Arduino. I connect the 5 volts here. Okay, I put my 5 volts here. Bam. So okay, now I connect my resistor from the 5 volts. I connect my resistor. Okay, sorry. Okay. I connect my 5 volts. I connect a resistor, making a contact. Okay, so this is my resistor. I will just connect it to 5 to this. I'll connect it to this. Now I connect the positive leg to the same line. I'll jump it over. So let me jump it over to another 5 on the other line. So positive. Then I connect my negative on this line. This is my ground. I connect it here. Okay. Finish. Then I need a jumper to complete it. So I need a jumper to complete it. Or I can go directly here to complete it. Whichever one. You can see it. See the connections? Very simple. See the connection? It's very simple. It's very simple. So this is it. So very simple. So this is just what we just did yesterday on our program, on our blinking program. We just transferred it to the breadboard, so we can now also call up the program again. I've already saved it in the system. I have saved it. We can now connect our Arduino so that we can call the program back again, and we can also demonstrate. Okay, so so this is our program, and we have our Arduino. So we connect our Arduino so that we can now see. Okay, so the program I've already saved it, so it's already saved program, so it will be running. Then if I also change it, you can see, so it's running. That's the program we did on our last tutorial. Is now running because it's already saved. It's in the chip. So if I want to change it back again, I can still do on the program. I can change it to, this is okay, we have 100. I can change it to 5. I can change it to 5,000, and I will upload. Let's upload and see. Okay, you can see it now. Okay, now we have changed it to 5,000 milliseconds. That is 5 seconds to come on and 5 seconds to go off. So 5 seconds to come on, 5 seconds to go off. So today's program, today's tutorial is all about the blinking. It's all about the blinking tutorial using breadboard to see actually what we have done. To use breadboard to see actually what we have done, and you can see with the same program we did yesterday, you have learned how to use breadboard. You have learned how to use breadboard to do the same program. So breadboard is very easy to use if you understand how it works. It's a very simple board. If you learn it very well, know how you can use it, it will make your work neater and easier. So that is it. And okay, not too much thing about. So we can still, okay, we can now add our buzzer. We can add our buzzer to that, and let's see how we can do it with the buzzer. Okay, we are good to go. So now, so let's put a buzzer. Let's see how we can remove an LED then we'll add a buzzer to it. So this is the negative side of my buzzer. The negative side, I connect to the negative side. Now this time around, I'll connect it here. Then okay, I will remove the LED resistor. I'll remove it so that I will not tap too much current from the IC, from the chip. So I don't want to run both the resistor and I don't want to run both the LED and the buzzer at the same time. I don't want to combine the load, so it may be too much for my integrated circuit for my chip. So I will remove this resistor. It goes off, then I'll connect directly to the line. So you can see it. Okay, it goes off, it comes on again. So very simple. So it's as simple as A, B, C, D, E, F. Now we can now change the values to 1000. You can change the values to 1000. Okay, so let's change the value to 1000 and see. So let's load this one. Okay, you can see it. Okay, so let's change it to 500. Let's change to 500. Okay, good. Let's change to 100. Wow. Okay, so this is where we'll call it a day on today's tutorial. So we have seen and we have also learned how we can use breadboard with Arduino Uno to do our practicals. So the same thing applies to every component we are using here. So the same application, so the same component. So Arduino programming is as easy as A, B, C, D. So if you understand the basic principles and you understand the hardware arrangement and you know basic electronics, you'll be able to flow. So okay, thank you very much and God bless you. And this is where we'll call it a day on today's tutorial on how to interface a breadboard with your Arduino and your components. Thank you and God bless you. See you next time on our next tutorial on variables. How to use variables. How you can use your variables and how you can use your variables to work. So on the next tutorial, we are going to deal on variables and some other programming stuff. So God bless you. Thank you very much. And your one and only Mr. Great. Bye-bye.